Hi, I am Esteban Parra and I am presenting our experiences building an answer bot for Gitter. This work was done in collaboration with Ricardo Romero and Dr. Sonia Haiduc at Florida State University. Nowadays, developers have started using instant messaging platforms to communicate with each other, especially when you're dealing with distributed development teams. They will use these platforms to communicate with each other and coordinate their efforts during the development of the project. A recent study by Kaffer et al. Found that Gitter is actually the most popular instant messaging platform in open source development. Developers can ask questions in these channels. They are usually chats, so they can ask questions to other developers to get responses in real time. However, we find that some of these questions may not require a specific knowledge from the developers on the project to be answered, and they might have been already answered somewhere else. To address these questions and help developers to focus on the questions that do require project-specific knowledge, we devised the GitterAns Framework. In our framework, we have that whenever a developer posts a new message to the channel, we analyze the message and then it will move on to our three components. The first component is the question detection component. This component will analyze the message and determine if it is a technical question or not. If the message is not found to be a technical question, it will stop processing the message at this point. If, however, the message is found to be a technical question, the message will be moved on to the second component of our framework, which is the search for answers component. In our search for answers component, we take the original message posted by the developer, send it to a query, send it as a query to a custom Google search that will search on Stack Overflow and return a JSON result with the top posts from Stack Overflow that are found to be related to the original message. Once we have this JSON with the results of the answers to this question, we move this to our third component, which is the answer processing component. This component is mostly in charge of parsing the JSON result and posting that result as a new message to the Gitter channel where the original question was posted. Here we see an example of how the framework works. On the left side we have our framework, on the right side we have a set of messages that have been posted to a Gitter channel. So first we have one message that was posted by the developer. So for the question, it was sent to our GitterAns framework. Then it was deemed to be a question. It was posted here as the question, and then the result that the search for answers component found using the Google custom search is posted as an answer, as a new message into the channel itself. So in here we can see the top 3 posts that were found to be relevant in Stack Overflow. Afterwards, we see 2 messages that are deemed not to be technical questions, so they are left as they are. Then when the user posts this next message, that one is also found to be a technical question, so I'll go back to our GitterAns framework, found to be a question, and the answers that, or the potential answers found by the framework, and then posted as an answer to the channel. For evaluating our framework, we had first to create a dataset, because there is currently no existing dataset that distinguishes between technical questions and not technical questions messages in instant communication messages. So first we found the messages from the Node.js chat room in Gitter. We extracted all of the messages that were on the channel. Afterwards, we explored a sample of 1700 messages, and then we identified a set of representative engrams that were found commonly in messages that were technical questions. Using these engrams that we found, we developed an engram filter to filter out the original 9,000 messages based on these engrams, and found a subset of 6,400 potential technical questions. After this, we started a manual labeling effort in which we labeled 1,000 potential technical questions. So for each message, an author will explore the message, read through it, and determine if it is a technical question or not. After inspecting 1,000 messages, we arrived to our ground truth dataset, which contains a total of 359 technical question messages and 631 messages that are not technical questions. Having this dataset, we were able to perform our preliminary study. In our preliminary study, we are dividing the evaluation into two parts. The first part will evaluate the classification component, the detection of the questions, and the second one is evaluating the search for answers component. For evaluating the question detection framework, we explored three different machine learning classifiers and used hyperparameter tuning with tenfold cross validation using the dataset that we developed on the previous process to evaluate these machine learning classifiers. In particular, we explored the naive-Bayes, stochastic gradient descent, and random forest classifiers, which are very popular in the software engineering machine learning applications. For the second part of the preliminary study, we ran our GitterAns framework on 20 random questions that were found to be troubleshooting questions and manually inspected the results to determine if within the top 3 answers found by the GitterAns framework, one or more of those posts answered the question that was originally posted by the developer. In our results for the search for answers framework, we have some mixed results. First, we found that for 11 of the 20 technical questions in our preliminary study, GitterAns was not able to provide a Stack Overflow post that properly answered the question within the top 3 results, which were the answer given by our framework. However, for the remaining 9 questions, GitterAns was able to recommend a Stack Overflow post answering the question as the first recommendation. As far as the detecting questions component, our experiments showed that the stochastic gradient descent classifier performed the best with an accuracy of 0.78. Now, when we were looking through the results of our search for answer component, we found that for the 51% messages that were GitterAns was not able to provide a meaningful Stack Overflow post answering the question, we found that if we removed noise from those messages and leaving only the core question primary information and run the Google custom search on that, we were actually able to get answers to those messages questions in the same manner that we did for the 49% that we actually found answers. So what this tells us is that there is noise in those messages that we need to curate. So this is going to be our future work, is to find a way to automatically remove the noise from these messages that contain technical questions in order to improve the results of the search for answers framework. We also plan to work on improving the classification messages. 0.78 of an accuracy is a good starting point for a classification application, but we want to improve this result to make sure that we do not answer questions that may not be technical questions and provide answers for them, because that will decrease the likelihood of the users adopting the tool. Lastly, we want to also perform a large-scale evaluation of our GitterAns. We performed a preliminary study on a small dataset, on a small set of questions. We will want to produce a large-scale evaluation with developers to properly evaluate the usefulness of our framework. We also can see the benefit of using historical results, so questions that have been posted to the channel before, and using those answers that were already found, rather than parsing the message and sending to the Google custom search over and over again to answer the same question. So we'll plan to use the historical results from our framework to decrease that workload. I'm here for any questions. Thank you.